This is a problem that is similar to something you might see on a coming assessment or final exam. It says solve and graph g of x equals x cubed plus 2x squared minus 5x minus 6, given that x equals negative 1 is the solution. So if I'm ultimately trying to graph this, I want to see what kind of general overall end behavior I have. So this leading term tells me that I am starting from low, ending high, because it is positive x to the odd power. I also can see I have a y-intercept of negative 6. All the things in the middle I don't know yet, but I know that negative 1 is a solution, so one of my x-intercepts is negative 1. And so now we can set up a long division problem, and I'll show synthetic division, which is a very procedural shortcut next. We have x cubed plus 2x squared minus 5x minus 6, and I'm dividing by the factor that would have negative 1 as a solution. So if x equals negative 1 as a solution, x plus 1 is the factor. So I'm going to divide by x plus 1. And I start by saying, hey, how many times does x go into x cubed? Well, this suggests x squared times. So I'm going to enter here with an x squared, and I'm going to multiply times both terms. X squared times x is x cubed. This should exactly match the term above it if you've done it right. X squared times 1 is 1x squared. And this is a plus. And so just like in normal division, I'm going to subtract. X cubed minus x cubed is 0, and 2x squared minus x squared is 1x squared. And I'll bring my remaining terms down. Now I'm going to look to divide this x into 1x squared. So I'm really asking myself, what's x squared divided by x? Well, that's x. So that's what I will have my next term in my division be, a positive x. And I'll multiply this times each term. X times x is x squared. X times 1 is 1x. And that was a positive 1x. And now I'm going to subtract again. 1x squared minus x squared is 0. That's what it should always be for the first term. And a negative 5 minus 1 will be negative 6x, bringing down the negative 6. I've got negative 6. So now I'm really saying, what is negative 6x divided by this leading x? Well, that's equal to negative 6. So that's what goes up here to multiply. I'll multiply each term again. Negative 6 times x is negative 6x. Negative 6 times 1 is negative 6. Now when I subtract, it's the same thing as distributing this through, making everything positive, and I can add. Or you could have just subtracted a negative. Either way you get 0, x, plus 0. The fact that I have 0 as a remainder means exactly what I thought, that negative 1 is a solution, making x plus 1 a factor. So that means my factors are x plus 1 times what was left up here above the division bar, x squared plus x minus 6. To continue the problem further, I would factor this and get x plus 3, x minus 2, and my original factor of x plus 1, meaning I have zeros at -1, -3, and 2. Now I can make a better sketch, load a high, through my y-intercept, and back to the end. It matches my end behavior. Now, I'm going to show the same process using a shortcut called synthetic division. Synthetic division is quicker and very procedural, so if you make a simple mistake, you'll get the problem all wrong. It starts by representing everything under the divisor as the coefficient. So this is really a 1. I'd have 1, 2, -5, and -6. And I'm dividing by the 0 this time, not the factor. So -1 comes right in here. And again, it's very procedural. I'll start by bringing the 1 down. And now I multiply. -1 times 1 is 1. And now I will add, and that's always the next piece. 2 plus 1 is 3. Now again, I will multiply this -1 times 3 and get -3. I need to go back a minute. I've made an error. My first step was to multiply -1 times 1 and get -1. When I add, I get 1. Now, I have -1 times that 1, and I get -1, and I add again. -5 plus -1 is -6. -1 times -6 is +6. I add and get 0. The fact that I have 0 as a remainder means that I have done it correctly. It means that x equals -1 is a 0. That means x plus 1 is a factor. It also means that what you see here are the coefficients of the other factor. So I've got 1x squared plus 1x minus 6. The same thing we got doing it the other method. So my factors are x plus 1, x squared plus x minus 6. You'll see that either method gives you the same thing, and factoring here, I still get x plus 3, x minus 2, or if you wanted, you could set up another synthetic division problem, 1, 1, and -6, divided by what you think other zeros might be. We know one of them is 2, so I'll show you. 2, bring down the 1, 2 times 1 is 2, add 3. 2 times 3 is 6, add 0. That means my last factor is this right here, 1x plus 3. If 2 was my 0, then my other factor is x minus 2, and my original factor was always x plus 1. two ways using long division and synthetic division to get to the same answer of finding zeros and ultimately drawing graphs.